Hi everyone. Apart from the separable variables, there is another classic way to solve a first-order ODE. But this time, with the integrating factor, we are solving the first-order linear ODE. So here, let me introduce to you the very nice looking integrating factor. It's called mu, which is also a function of x. If your ODE is a function of t, change your mu as a function of t. So here, let's say that I have this first order ODE, which is linear as you can see, because p and q are respectively functions of x. Okay, so now to introduce the integrating factor and eventually to find our y, let's just go ahead. Y prime plus py equals to q, right? And now I'm trying to put the integrating factor inside. So both hand sides, for every term, I just multiplied by a mu. It is possible, right? And the trick is now I'm trying to make the left-hand side collectively put it as mu y prime. What is that? Mu y, let's take a look. Mu is a function of x, y is a function of x. Those two functions, if they are multiplying with each other and take differentiation, we're going to use product rule, right? What do we get with the product rule? We are going to have mu y prime, let's say, and then plus this time I keep y and take differentiation of mu. So I have mu prime y. And the left-hand side, I would like to collectively put it to as in the form of mu y, the whole thing take differentiation. It is possible because it would facilitate us, okay, to find the mu. So here we go. I have mu y prime already, okay, but on the second term, I actually have mu py. Since mu is unknown, okay, p is known because it's given in the equation, but then I can actually set, okay, mu prime y equals to mu py. So essentially, y and y, we just don't care about them, and essentially, mu prime would be mu p then. Okay, and now, what is mu prime? Mu prime is actually d mu dx, okay? So in this case, I can actually put mu and d mu together, and that I'm going to have d mu over mu, okay? On the right hand side, I have p dx. This is easy because I have p as a function of x and mu and with d mu. So again, I can integrate them, okay? So on the left hand side, what am I going to get? Something like natural log of mu, okay? And would be equal to the right hand side. I have integration of p dx plus a constant, okay, because I put the constant from the left hand side to the right hand side collectively. So now I can say that my mu would be e to the power integration of p dx plus constant, okay. And of course, plus constant, I can write it as e to the power integration of p dx times e to the power c, right? That's the same thing. So here I can collectively write e to the power c as a. So normally you will see that the mu would be in this form here. Okay. So this would be our integrating factor. And you can see that a is just a constant, and then I have e to the power function of x. So my mu is in fact a function of x, and it is called the integrating factor. How am I going to use the integrating factor in our solution? Let me show you now. Now let's take a look at this first order linear ODE. To use the integrating factor, we need to have the equation as y prime plus py equals to q. So now we have x in front of y prime, so we have to get rid of it by dividing the whole equation by x. So on the right hand side now I have x, and this is good because now I can extract this p out. Okay, so p is actually negative 1 over x then. Okay, so now the mu, essentially if you don't do the derivation again, I'm going to have mu equals to a times e to the power integration of negative 1 over x dx. Okay, if you integrate this negative 1 over x dx, you're going to get negative natural log of x. Okay, and essentially you can write it as natural log of 1 over x then. Okay, so here I have natural log of 1 over x, and it's on top of this e function. So exponential of a natural log, essentially they are cancelled out. So I have a times 1 over x then. Okay, or you may write it as a over x. So now I have the integrating factor. I want to show you how we are doing the solution. So remember, we were trying to make mu y prime equals to mu q. Okay, so because that is the left hand side that we were aiming at, and in this case I can actually plug in the mu already. So I have a over x here, so I have a over x times y, the whole thing take a prime, equals to the mu is a over x times our q is here. Remember, once we modified our equation, the q essentially on the right hand side is x. Okay, so now I can cancel them out, and essentially you can see on the left hand side and the right hand side I have the same constant. This is a, so I can cancel them out, and in fact for every equation the integrating factor would be normally rewritten as e to the power integration of p dx, only because this a eventually would be cancelled out once I balance the left hand side with the right hand side. So in general, I would just take the mu without the constant. Okay, so now let me just rewrite the equation. So I'm having y over x, the whole thing prime, equals to the right hand side now is 1. Very simple. And how am I going to solve it? Remember, prime means that I'm taking d of y over x with respect to x. Okay, so I'm trying to put the dx to the right hand side. I'm actually having dy over x equals to dx now, and I can easily integrate it. Okay, when I integrate, I'm going to have y over x on the left hand side, and the right hand side, once I integrate it, I'm going to have x plus a constant. Okay, so collectively on the left hand side originally it should have a constant, but on the right hand side it has another constant. I would just collectively call it c on the right hand side. So now y is x squared plus cx. Be very careful. Normally when you will remember to multiply the x by x, but then the second term also would have x now. So in fact, this is our y, and our y prime would be, take differentiation, I'm having 2x plus c now. Okay, so still have the constant because the constant was multiplied by x when we had y. Okay, so now this is good, and I can, why do I want to take the differentiation again? Because I want to verify. Let's say that I have this equation. How do I know if my solution, this y equals to x squared plus cx, is correct? So I'm going to plug in my solution back into the equation. So I'm going to have x times y prime, which is 2x plus c, and then minus y is actually x squared plus cx. Okay, so this is my left hand side. And then I'm trying to balance them, and I'm having 2x squared minus x squared, I have x squared, and then I have cx minus cx, which is 0. So essentially I only have x squared on the right hand side, and that is actually the right hand side that we are looking for originally. Okay, or of course you can also plug in the y into the second equation because the modified equation is still the same. Okay, so but on your right hand side would be just x then. Okay.